Good morning, students.
Good morning.
Good morning, ma'am.
Good morning. All of you, please switch on your videos.
Ma'am,
Yes, Shivanya.
for the first term exam from physics, which all portions are there?
For first term exam, we have two chapters, motion and force and laws of motion, the second chapter, chapter 9. So today we are going to start the second chapter, force and laws of motion. I request, okay.
Chapters one more time.
Yes, Prarthana.
Ma'am, can you say the portions one more time?
Two chapters, motion. The second one, force and laws of motion. Force and laws of motion is actually theory chapter. We can finish as far as possible with some 3 laws that put forward by Newton that regarding with that of the motion of an object. Already we discussed about the motion and the different types of motion, equations of motion in our first chapter. Now in the second chapter, we are going to discuss the 3 laws associated with the motion of an object. Those who are not facing any kind of network issues, please switch on your videos. Okay, children. So in the previous chapter, we discussed about motion. What do you mean by motion? What do you mean by motion?
Ma'am,
Change in the position of an object with respect to time.
Position of an object with respect to time.
Yes, very good. Change in the position of an object with respect to time is known as motion. So in our previous chapter, we discussed about what do you mean by motion, what are the different types of motion, and we derive the equations of motion and the terms associated with the motion of an object and all. But in that chapter, we are not discussing what is the real cause of motion. What is the real cause of motion or how this motion is occurs? Which factor is responsible for motion?
Gravity.
Is it gravity? Gravity only responsible for the motion of an object? Yes, it is the force. The force is the reason behind the motion of an object. So that is what is we are going to discuss in this chapter. So all of you write the next heading, force and laws of motion. Chapter 2, force and laws of motion. Force and laws of motion. Have you heard about this term force?
yes, ma'am.
Yes. Then what do you mean by force? Can you form a definition for
Push or
force?
a pull.
Yes, very good. This is the exact definition that we can give to the force. It is a push or pull on an object. I hope that all of you are visiting the shopping malls or a bank, right?
Yes,
When we are
ma'am.
standing near the doorsteps, we can see something is written on the door. What's that?
Ma'am, push.
Push or pull. If you want to open the door, which action that we need to perform there?
Ma'am, push.
Yes.
Push.
Yes, we need to push the door in order to open it. If you want to close the door, which action we need to perform there? Pull. So this is what is, so from this we can say that the push or pull on an object is the reason which causes the motion of an object. So this is the small and basic definition that we can give to the force. So what do you mean by force? Force is defined as the push or pull on an object. So all of you write the definition for force. This is the small and basic definition for force. It is the push or pull on an object. Force is defined as the push or pull on an object. Or technically, we can define force as an external influence that can bring changes in the position of an object. Suppose here I have a pen. Okay. Here I have a pen in my hand. I want to change the position of this pen from here to somewhere. So if I am kick the pen, what happened to it? Yes, it
I'm
is.
changing positions.
Yes, it changes its position. So here by applying the kick, that is I am exerting or I am applying an external influence. So the force is an external influence that can bring the changes in the position of an object. So technically, we can define force as an external influence. All of you write the technical definition for force. It is an external influence. It's an external influence that can bring changes in the position of an object. That can bring changes in the position of an object.
Can you say one more time?
The force is defined as an external influence. It is defined as an external influence that can bring changes in the position of an object.
In technical.
In technical language, this is the technical definition for force. In simple terms, we can define the push or pull on an object is known as force. So this is what is the definition that we are already studied in our lower classes. Now you are in 9th.
Can you say one more thing?
Okay, so in technical means force is defined as the external influence. It is defined as the external influence that can bring changes in the position of an object. It is an external influence that can bring changes in the position of an object. So force is an external influence. It is an external influence. It can be either push or pull. It's an external influence. As a result of external influence, what causes to the position of an object? The position of the object is undergoes changes. That is what is we are known as we are called as motion. So it is an external influence that can bring changes in the position of an object. That can bring changes in the position of an object. So here we discuss the two definitions for force. One is a simple and basic definition, and the second one is the technical definition that we are normally used to define the force. Now, what are the characteristics of force? Write the next subheading, characteristics of force. Characteristics of force. How we can represent the force? The physical quantity force is represented by which letter?
Yes.
Yes, very good. The force can be represented by capital letter F. The force can be represented by capital letter F. SI unit of force is, do you know the SI unit of force? How we are express the force of an object? Force that is experienced by an object is expressed in terms of Newton. Okay, SI unit of force is Newton. Because it was Sir Isaac Newton who gave the idea about this force that acting on an object, and thereby he formulated the fundamental laws of motion. So SI unit of force is Newton, and it is represented by the letter N. Capital letter N is used to represent force. The SI unit of force is Newton. It is represented by capital letter N. Now the third characteristic for force. Force is a vector quantity. Force is a vector quantity. What do you mean by this statement? Force is
It
a vector.
only has one magnitude.
No, force
Ma'am
is
has both direction and
very good,
magnitude and
excellent.
direction.
Because it possesses both magnitude and direction. Force has both magnitude and direction. That is why we can say that force is a vector quantity. So in our previous chapter, we differentiate between vector quantity and scalar quantity. The physical quantity that possesses only the magnitude, then we can call it a scalar quantity.
Scalar
But here,
quantity.
yes, but here the force is a vector quantity because it has both magnitude and direction. So these are the three characteristics of force. Force can be represented by which letter, Shankari? How we can represent force?
F capital.
Capital letter F. And what is the SI unit of force? Asin? SI unit of force? Asin? Unmute and say dear. Newton. Ashmit, identify the type of physical quantity. Force.
Vector quantity.
Very good. Force is a vector quantity. Krishnaveni, why the force is known as a vector quantity?
Because it has both magnitude and direction.
Yes, very good. Because it has both magnitude and direction. Now here you can see Galileo Galilei and Sir Isaac Newton. These are the two scientists who put forward the idea of force into physics. So initially it was believed that we know that when object is in motion, suppose if a football or simply the ball, it is in a rest position, and if we are applying an external force on it, it started its motion. After sometimes what happens to the motion of this football or ball becomes, is it continuous infinitely?
No.
No, after sometimes the motion of the ball becomes stop. So in earlier days, it was believed that the rest is a natural tendency of an object. Because all the object is always in a state of rest, the motion is not possible. Then after that, the concept of motion is better explained by these two scientists, Galileo Galilei and Sir Isaac Newton. So now we are going to discuss the different effects of force. So here we discuss the definition and the characteristic of force. Now the different effects of force. The first one, a force can move a stationary body. A force can move a stationary body. Can you give me one example for this effect of force? A force can move a stationary body. Stationary body means an object which is at rest.
Ball.
Yes, a ball.
The car.
A bicycle.
Yes, bicycle. How the bicycle becomes move?
When we start pedaling, it moves.
Yes, when we are apply the force to the pedal, the bicycle starts to move. Very good. So a force can move a stationary body. Now, the second effect of force, a force can stop a moving body. The second effect, a force can stop a moving body. Give me
Ma'am,
one
a car.
example.
Ma'am, car.
Car.
Yes, car stop its motion. How?
Ma'am, are you playing brake?
Brake.
Yes, when we are applying the brake, the car stop its motion. So while we are applying the brake, here we are exerting an external force. Thereby we can stop the moving car. So a force can stop a moving body. Now the third effect, a force can change the speed of a moving body. A force can change the speed of a moving body. Vishal, give me one example for this effect of force. A force can change the speed of a moving body.
And when we apply the acceleration on the car.
Yes, very good. When we are applying the accelerator on the car, the speed of the car increases. By applying the accelerator, here we are applying an external force. Thereby, the speed of the object or speed of that moving vehicle increases. A force can change the speed of a moving body. Now, the fourth effect of force, a force can change the direction of a moving body. And Leah Sabu, can you give me one example for this effect of force? A force can change the direction of a moving body. Any one example from our daily life? A force can change the direction of a moving body. Abhishek? Anyone? Try to guess one example for this effect of force. That is, a force can change the direction of a moving body.
Ma'am,
Change
while we are
direction of
pedaling a
steer.
bicycle, if we
Or-
turn,
Yes, if we turn by pedaling the bicycle, then the direction of that bicycle becomes changes. Similarly, while we are driving, while applying the force, yes, while we are driving, while applying the force on the steering, what happened thereby we can
will be
change
turned.
the direction of that moving car, right? Then the last effect of force, a force can change the shape of a body. A force can,
force on a ball.
yes, very good. By applying the force on a ball, does the shape of the ball changes?
And when we do it, ma'am, a piece of paper, when we are
Yes, when we
applying
are applying
force.
the force on a piece of paper, the shape becomes changed. And then any more example, anything else? Here I brought one rubber band here. So what about the initial shape of this rubber band?
circle.
In circle. Now I am applying the force. I am pulling it. What happened to the shape?
Ma'am, it stretches.
Stretches, it becomes elongates. Does the force, does the shape of the rubber band changes here?
Yes, ma'am.
Yes, so these are the different effects of force. So what are the different effects of force? Raulgar, what is the first effect of force? Can you say any one of the effects of force? Raulgar, Roy? Any one of the effects of force? Unmute and say, dear. The same question to Alana. Alana Jinson. Yes, I can hear. Yes, the force that is starts a moving body, or force that starts a, okay, force moves a stationary object. Okay, Gobi Krishna, another effect of force. Unmute and say, Gobi. Vinayak, any one effect of force? Unmute and say, Vinayak. Unmute.
Force can change the speed of the moving body.
Force can change the speed of a moving body. Okay, Alia.
Ma'am, it can change the shape and size of a body.
Very good. It can change the size and shape of a body. Catherine. Any other effect of force?
Yes, ma'am.
Any other effect of force? Here we are discussing nearly 4 or 5 different effects of force.
Force can change the speed of the moving body.
Okay, the force can change the speed of a moving body. Then next one, who is here? Fatima Shasa. One more effect of force. Prarthana.
Ma'am, a force can change the direction of an object. or a
Okay, the
moving
force can change the direction of an object or a moving body. All right. So who is ready to recollect all these different effects of force? Tia, try to say all the different effects of force. Okay. Okay, sorry, dear. I think some network issues. Okay, continue. Hmm. Okay, then same question to Midun. What are the different effects of force?
A force can move a stationary body.
Okay.
A force can stop a moving body.
Can stop a moving body. Then
A force can change the speed of a moving body.
it can change the speed of a moving body. Then
A force can change the direction of a moving body.
It can change the direction of a moving body. One more. Rubber band.
Shape.
Okay, it can change the size and shape of the object. Okay, force can change the shape and size of the object. Now, depending upon the force, whether the force can be felt or not, we can classify the force into two types. They are balanced force and unbalanced force. So all of you write the next heading, types of force. There are two different types of forces are there. They are balanced force and unbalanced force.
Ma'am, depending upon
Whether the force is felt or not. Whether the force is felt or not, we can classify the force into two types. One is balanced force and other is unbalanced force.
One minute.
Okay. Depending upon whether the force is felt or not, we can classify the force into two types. They are balanced force and unbalanced force.
Can you repeat the point?
Depending upon whether the force is felt on a body or not. Depending upon the force is felt or not, we can classify the force into two types. They are balanced force and unbalanced force. Balanced force and unbalanced force.
Okay, ma'am.
So we can discuss this balanced force and unbalanced force one by one. First of all, you write balanced force. Balanced force. Write the first heading, balanced forces or balanced force. What did you observe in this figure? You don't need to concentrate or focus on these words. Try to focus on the figure. What did you felt here?
A man sitting on a chair.
Yes, very good. Simply a man is sitting on a chair. Does he move?
No.
No. Why he is not moving when he is sitting on this chair?
Because he is a
Stationary.
Because he is applying a force on the chair. Because
Yes.
here applying a force on the chair. At the same time, the chair is exerts a force on the man, but it is in the opposite direction. Okay. So here there are two forces are acting at the same time. The first force is the force which is acting downwards. The person is acting a force or into the chair that is in the downward direction. At the same time, the chair is exerts an upward force. It is exerts a force on upward that is in the opposite direction. So suppose you imagine if this person is exerts a force that is equal to 10 Newton to downwards. At the same time, the chair is exerts equal force that is 10 Newton itself. It is in the opposite direction. So in effect, what will be the resultant force acting on this particular case? What is the total force? F is equal to
20.
It is not 20. 10 Newton to downwards plus 10 Newton to upward, that is in the opposite direction. So you must put a negative sign here. Here
Ma'am,
the
it get
two,
cancelled.
yes, very good.
Cancelled.
It get cancel out each other because here equal and opposite forces are acting on a particular body. So they will cancel each other. So in effect, we get 10 Newton minus 10 Newton, that is equal to 0. So the net force acting on this case is equal to 0. So that is why the person doesn't move from the chair. He is sitting comfortably. So this is what is known as balanced force. So what do you mean by balanced force? These are the equal and opposite force that is acting on an object. As a result, the resultant force of an object becomes equal to the resultant force becomes equal to Zero. Because they are cancels each other. One force is acting downwards. At the same time, another force is acting upwards. They are equal in magnitude. Because in both cases, we are considering 10 Newton and 10 Newton. They are equal in magnitude, but opposite in direction. So they will cancel each other. This type of forces are known as balanced force. So what do you mean by balanced force? When equal amount of force are applied on an object from different direction. Instead of this different direction, you can write from opposite directions such that they cancel out each other. When equal amount of forces are applied on an object from opposite directions such that they cancel out each other. Such type of forces are called balanced force. When equal and opposite force acting on an object, they will cancel each other. Such type of forces are called balanced force. Or in simpler terms, you can define this balanced force as if the resultant force acting on a body is equal to 0, if the resultant force acting on a body is equal to 0, then we can call such forces as balanced force. If the resultant force acting on a body is equal to 0, then we can call such forces as balanced force. You can write any one of these two definitions. When equal amount of force are applied on an object from opposite direction such that they cancel out each other, this is also known as balanced force. Or you can write if the resultant force acting on a body is equal to 0, then we can call such forces as balanced force. And what are the characteristics of balanced force? They do not change the state of rest or motion of an object. They do not change the state of rest or motion of an object. Don't need to copy down the second point.
I wrote that point.
Okay, then no problem. Only need to study any one of the characteristic of balanced force. They do not change the state of rest or motion of an object. So this is what is known as balanced force. So if the resultant force acting on a body is equal to 0, we can call such forces as balanced force. Then students, can you form a definition for unbalanced force?
Which will be not equal.
When unequal amount of forces are applied on an object.
Very good. If the resultant force that is acting on a body is not equal to 0, then we can call such forces as unbalanced
Ma'am.
force. Yes.
Ma'am, second characteristics we should write.
Yes, if you write, no problem, you can copy down. You need to study any one of the characteristic of balanced force. They do not change the state of rest or motion of an object, or they may change the shape and size of the object. In some cases, yes.
Ma'am, attendance.
All right. Now you just copy down the definition for unbalanced force.
We should write the characteristics of force.
Yes, characteristics of unbalanced force also.